Hey everybody. So in this video, we are talking about angles in standard position. So before we jump in and start doing these problems, I do want to show you just a couple of things as an introduction to angles. So when I'd say an angle in standard position, angles have two components, all right? You have your initial ray. The initial ray is always going to be along the x-axis. It is always going to be on the positive side of the x-axis. Okay? So the initial ray is always here. The terminal ray determines the size of the angle. So here we see that we have some acute angle. Here, this is some obtuse angle because it's larger than 90. And then here, the angle starts to get really big because now the angle's more than 180. Now it's more than 270. And we're almost back at 360. So these are angles in standard position. Now, let's talk about the way you'll see angles in standard position. So here, anytime in a math book or in math problems, they'll always notate which side is the terminal side because there always will be an arrow that points to the terminal side. So in this illustration, I don't have to tell you this is the terminal side because of the arrow. The arrow is always going to point to the terminal side. And then here you have what's called a reference angle. Now, we're going to talk about this a little on the next video, but right now I want you to know that whatever the reference, you can use a reference angle to determine the size of this angle. So I know this says 60.67, but I mean that's ridiculous. Why are we going to use this? Okay, I don't know why they didn't just make this thing count by integers, but let's just say the reference angle is 60. Okay, well if this is 60 degrees, then how many degrees would this angle be? And that would be, 120 because we know that this is a linear pair. We learned that in geometry. So the two sides of any angle have to add up to 180. So we're going to use reference angles to find the measure of angles in standard position. So that's what you'll see right here in these notes. So you'll notice that right here, it says find the measure of each angle. So here we have an arrow that is pointing to the terminal side. And I want to know, now this 40, don't get this confused. This is the reference angle. This is telling you how far or how many degrees you are, the terminal side, from the x-axis. This is not the measure of the angle. I want to know what is the measure of this angle right here. And that's what we're going to be doing. So let's take a look at how we would solve this. So if this is 40 and this comes all the way around, I know that this is 90, here's 90 again, here's 90 again, and this whole thing is 90 degrees. Well, they've taken away 40 of those 90 degrees, so that means this has to be 50. So all I really have to do is add up these angles. So I can say 90 plus 90 plus 90, that's 270, and then 270 plus 50, that is going to be 320 degrees. Now, you may also say, Mr. Phillips, there was a much easier way to do that. I already know that in a circle, there's 360 degrees. So couldn't I just say 360? Let's make this much smaller. Sorry about that. So here, couldn't I just say this is 360 minus 40 and get the same answer? Absolutely. You can do whatever you want in these. Many of these, there are several ways to get the right answer. Now, let's talk here. One, we got a lot of things happening. We have a reference angle that is in radians. And now look, do you see how this angle is moving clockwise? Where this angle, that terminal leg, was moving counterclockwise? Okay, here's what you have to know. Angles that move clockwise are negative angles. So here I've traveled negative 360 degrees or negative 2 pi radians. Remember, we can't forget about our radians here. And now, how much further did I travel here? Now, when I have done this in the past, my students, they don't really like working with radians. They think working with degrees is so much easier. Well, that's perfectly fine. We talked about in the last video how to convert from radians to degrees. And what we do is we multiply by 180 over pi. And now this will give me this radian value in degrees. So here, this 9 reduces, this turns to 20, and now I have 4 times 20, which is 80. So here, this is 80 degrees. So that's the measure of the reference angle. So that means this little bitty part in here is 10 degrees. So now let's think about it. I went negative 360, and then I went 10 degrees past that. So now this is negative 370 degrees. And you say, Mr. Phillips, why did you write it up here? Why didn't you just write that in the answer box? Because if they gave you the reference angle in radians, they want the answer in radians. Remember, think of a degree as how wide an angle is. And think of a radian as how far you had to walk to get there. So degrees and radians, we're kind of talking about two separate things. So I want to change this from a degree back to a radian. So here I'm going to multiply by pi over 180. And then this is going to give me negative 37 pi over 18. Now, don't worry about how crazy and ridiculous some of these look. As long as you're doing the math right, you are 100% correct. Okay, let's come over here and try this one. So here we have, this is still opening clockwise. So I know this angle is going to be negative, and I know this distance right here is 65. Well, I know that this whole distance should be 90. So I could just say 90 minus 65, and that is 25. Okay, now that is not positive 25. Remember, we just said if an angle, if the terminal side is moving clockwise, it is a negative angle. So this should be negative 25 degrees. Okay, let's look at this fourth one, 5 pi over 12. Now, I'm going to show you two ways to do this. Here, you have an angle that's opening clockwise, so I know that this is going to be negative. So we're going to start by doing it the same way we did problem number 2 over here. We're going to change this to a degree. So this is going to be 180 over pi. And feel free to use a calculator on some of these. Okay, so here if I said 5 times 180 and then I took that and divided it by 12, I'm going to get 75. So here I have 75 degrees. That's the measure of this reference angle. So here, that means if this is 75, this itty bitty angle is 15 degrees. Now, I've traveled negative 180, right? So here it traveled negative 180 plus 15. So that looks like it's going to be negative 195 degrees. Okay? Now, was that the right answer? It's the right answer in degrees. What did I forget to do? I forgot to make it a radian. So here I have to take negative 195, and I need to multiply this by pi over 180. So let me go ahead and erase this. If they gave us a measure in radians, right, our answer should also be in radians. So now I have negative 195, that is over 180, and that simplifies to be negative 13 pi over 12. Okay? Now, you can also do it another way. The other way I'm about to show you, some students don't always like because you have to work with fractions. And I know for some reason, I don't know why, but fractions appear to be the mortal enemy of most students. So let's think about what we did in a prior video. Here, we know that this is 0 pi radians. And then remember how we counted by pi over 4 and pi over 6? Right here, this was negative pi halves because we're going clockwise. This would have been negative pi, and this would have been negative 3 pi halves. Well, if you travel right here and get negative 3 pi halves, right, or negative 270 degrees, you can just backtrack 5 pi over 12. So here, you could say negative 3 pi halves, right, plus 5 pi over 12. right? You're backtracking. 5 pi over 12, right? That means because I have a negative distance and I'm backing up now. And then that, when you add these, you will get negative 13 pi over 12. Now, if you are like, none of that made any sense, I cannot stand working with fractions, forget fractions. It is so much easier. It may be so much easier to you just to take this radian, make it a degree, and then do all your work from there. All right, and that's perfectly fine. So let's try that. So here on this example, we got lots of circles. So like, whoa, Mr. Phillips, what does that mean? Okay, the circles indicate the travel. So here, think about this. I started here. I went all the way around in one circle. So we know that's 360 degrees. Then I went another 360 degrees. And then I went an additional 55 degrees. So we have 360. Let's color coordinate this. Nothing better than a little color, right? So here we go. 360 degrees. And now I have another 360 degrees. So here we're going to add 360 to this. And then I went an additional 55 degrees. So I'm going to add all of these up. So 360 and 360 is 720. 720 and 55 is 775. So here, this is 775 degrees. So that's what that means. Remember, if you are going clockwise, then your degrees are negative. All right? So I want you to pause the video. I want you to try these 3 examples. Try these 3 on your own, and then unpause the video, and I'll have my solutions pulled up. All right, here are my solutions. So right here, I changed pi over 4. I changed that to 45 degrees. And then here, this was negative 360 minus 180, and then an additional 45 degrees. So that gave me negative 585. So what I want to do is I want to say, okay, well, the answer was negative 585 degrees, but I want this measure in radians. So I had to convert pi over 180. Then I got negative 13 over 4 pi once I simplified. And then you see my work here. I did the same thing. So this pi over 6, I made it 30 degrees. These are all negative. So negative 360, another negative 360, and then I went an additional 30. So I just added those up, and I wanted it expressed as a radian. Okay? Now, let's talk about draw an angle with the given measure in standard position. Okay? So let's come back down here. Now, you may say, oh, what? How am I going to do this? I've never drawn a radian length before. That's fine. You know what you do know how to work with is degrees. So, hey, why not make this a degree? Let's multiply by 180 over pi, and we'll get this as a degree. Again, let's use that calculator. So I got negative 13 times 180, and I'm going to put that over 18, and that is going to give me negative 130. Now, negative 130 degrees and negative 13 pi over 18, they are the same angle. So here we know this is 0, this is negative 90, this is negative 180. So I know to get negative 130, I'm going to be somewhere in between here. Now, don't do something like this and be lazy, or something like that and be lazy, because you're a little too close. We know 130 is somewhere in between. So here's what we're going to do. We are just going to say, here is my my initial side. Here is my terminal side. And because it is negative, I'm going to draw my arrow going clockwise so that I know this is a negative angle. All right. Here, we got 310. All right, so we know this is 0. We're going counterclockwise because it's positive. So this is 180, this is 270, and then all the way back up here is 360. So here, we're going to be pretty close to that 360. This is our initial leg right here. And we're going to draw our arrow all the way around, showing how we traveled 310 degrees. Now, same as last time, pause the video. I want you to try number 3 and number 4, and then I'll put my solutions on the screen. All right, here is what you should have gotten. 7 pi thirds, and negative 270 here. This is how those should have been drawn. All right, that's going to be it for angles in standard position. If you have any questions, please leave them in the comments, and we'll see you all in the next video.